Hey, hello there. So today's Leetcoding challenge question is sort characters by frequency. We have an input string and we need to sort this string in the descending order based on the frequencies of the characters. Example, we have the input string to be word tree. We have three unique characters, T, R, and E. T appear once, R appear once, E has a frequency count of 2, so it has to count before T and R. And the relative ordering between T and R, it doesn't matter because they have a tie. So we can output EERT or EETR, both are fine. The second example, we have two characters, A and C. They both appear exactly 3 times. So in terms of the ordering between A and C, it doesn't really matter. But the problem is that we shouldn't mingle we shouldn't have this. They have to be grouped. The characters have to be grouped together. So if we just only sort the characters only by their frequency count in the reverse order, we might get something like this. So to sort the characters, if we have tie, we also want to sort maybe fourth order based on their characters. If we want to output CCCAAA, then we should sort the characters by the reverse frequency count. And if we see a tie, we will sort by the reverse order of the characters. So C comes before A. That way we will get this. If we first sort by the reverse frequency, then we sort by the increasing order of characters, we will end up with AAA, CCC. The third example, we have big A, small a, and 2B. So the output is BB, big A, small a. The relative ordering between big A and small a doesn't really matter, but we have to treat them differently so that the character B have twice the frequency count, so it should count before both A and big A and then small a. So that's basically the question. It's pretty straightforward. Basically, we're just gonna create a frequency count of the characters, then sort those characters based on their frequency in the reverse order, and then just piece together this string. So that's the time to create the frequency count will be linear with respect to the string, and sort depends on what kind of sorting we are doing. It should take k log k, where k is the unique number of the characters. That's the average case if we use regular sort. But here we actually can use some other kind of method, which I will talk about briefly after. And very lastly is just to construct a new string that will be linear time as well. So it's overall the time is 2m plus k log k. And the space complexity is k. That's for the frequency count, and then we should use at least the n to store the characters to finally build out the string. Depends on whether you want to count that or not. It could be either just k or m plus k. So that's the space and time and space analysis. Let's just create a frequency count first. It's the necessary step, no matter what kind of sorting you're using. So we create a map, which is going to be the character to their frequency. Just call it their char freq. What we're going to do is for every character in the string, we're going to increment the count for the frequency. And after that, we basically want to sort the characters in the reverse order of their frequency. So let's say we have AA, BB, CCC. The unordered map after we're doing this for loop, it will be A1, A1, B2, and C3. Let's say that we also have DDD. We'll have D3 as well. So we can create a list with this 2 things on the list, and sort first by the second element, the frequency, in the reverse order, then sort by the character. We can do that, or we can actually just create a bunch of buckets, and where the index is the frequency, and the value here is a list of the characters with that frequency. So as an example, we would have something like this, 4 different buckets, which each index here is representing the frequency. So in our example, we have from 0 to 3, and in each of the bucket, in the zeros bucket there's nothing. In the ones bucket we have character A. In the twos bucket we have character B. In the threes bucket we have C and D. So if you can just create this kind of bucket, then it's already in the sorted order. All the stuff that we need to create a string in a sorted order that's required. It's just enumerating over this list of buckets in the reversed order, from the right hand side towards left. If we find an empty bucket, we skip. If we find a bucket with stuff, we basically just repeat C for 3 times, then repeat D for 3 times, then move forward to the bucket to the left. Add 2 copies of B, add 1 copy of A. So the result is CCC plus DDD plus BB plus A, and just concatenating them all together to return that as a final string. That's just a really quick illustration of how bucket sort works in this case. So in order to do so, I guess we want a maximum frequency. That's our upper bound in there. Yeah, so let's just grab that as well. Maximum frequency. I can get this by either after the frequency count is created, just do one more for loop, or just along the way I can just keep track of the maximum. That would do too. So after this initialization of the construction of the frequency count, we know the maximum frequency, which is going to be the rightmost location in these buckets. Then we create this buckets, which is pretty much just a reverse mapping of this unordered map. This map is character to integer, the frequency. The buckets here, it's basically the frequency to a list of character mapping. It's the reverse. I'm just going to use a map. I think you can use vectors, collections with index as the, but here I think I could potentially save some space, because I imagine the frequency can be kind of sparse. So that will be int to a maybe a vector of characters. I'm just going to call this character order, order the character. I'm just going to call it order. So what we do is to enumerating over this map. We got a tuple for each of the tuple here are the pairs of key, character, and the frequency. I'm just gonna grab it for readability purpose. Character, just the C is T dot first, and the frequency is the integer is T dot second. And this frequency is basically now key to the buckets. So we try to populate the bucket if it's not if it's empty. Otherwise, we would insert the character into the bucket. So if the let's just call this buckets. If the frequency, so if the bucket for this frequency does not exist, we'll basically just creating it, and initially we just have this character in there. Otherwise, we would push the character onto the existing bucket. So after this for loop, we basically created another reverse mapping from the frequency to the list of characters. The final step is to stitch together the string. So we're gonna enumerate over the frequency in the reverse order from the maximum frequency to 0, or actually 1. And yeah, I can do greater than 1, right? No. For 1, I still want this loop to run, so just put frequency not 0. What we want to do is to look into the bucket, see how many characters are there, and how many, no matter how many they are, we're just going to repeat that character, that many characters for the frequency kind of times, and append it back to the string. For character inside the bucket, which is this. There's just one thing we need to do. Repeat these characters for this amount of frequency, and append that to the back of this resulting string. In the end, we just return the result string. So that's the code. Just quickly comment about this. Create char to frequent mapping. This is log n time and log k in terms of space. Then just create the buckets, which is essentially the reverse mapping. Frequency to list of char. The time is okay. The space is okay. And then finally is to reconstruct the string. The time complexity is order of n. So let's try the code. Nope. What's wrong? Oh, okay. I should test whether we do have a bucket in there. If buckets dot count frequency, then we actually do this. Otherwise, we just skip this bucket. Skip it with this frequency because there is no bucket. It should work. Yep. So that's the solution to this question. All right.